Welcome to The Explainer. Today, we're going to pull back the curtain on what it actually takes to learn artificial intelligence. And to do that, we're not just going to talk theory, we're going inside a real university course to map out the entire journey, from day one all the way to the final project.
I think it's a question on a lot of our minds, right? Because it's one thing to hear about AI all the time, but it's a totally different ballgame to go from just being curious to confidently building a working AI application. So what does that path really look like? To find out, we're digging into the syllabus and lecture materials from CS335. That's a real artificial intelligence course at Northeastern Illinois University. And this gives us a genuine, an unfiltered look at what a modern AI curriculum is all about from start to finish.
So let's break it down. What's the anatomy of a modern AI education? We'll start with the core philosophy because, honestly, how you teach a subject that's moving this fast is half the battle.
Okay, so the first thing that jumps out is the teaching method itself. You can just forget about long, silent lectures. This course completely flips the script with what they call a 30-70 rule. Only 30% of the class time is for the professor to talk, and the other 70%? It's all hands-on group work and discussion. The whole philosophy is crystal clear. You learn AI by doing AI. And here's the roadmap for the entire semester. You can see it starts with the fundamentals, a little history, key concepts, classic problem-solving stuff. But look how quickly it ramps up into the tech that's literally powering our world today. Machine learning, NLP, and even super cutting-edge topics like retrieval-augmented generation, or RAG, as you'll see.
All right, so every craft has its essential tools. And before you can build the kind of crazy, complex AI of today, you have to master the foundational logic of how a machine thinks. And that all begins with the classic problem of search.
So right at the start, students have to get this one critical distinction. Uninformed, or blind search, well, it's kind of like trying to solve a maze by just trying every single path, one by one. I mean, sure, it'll get there eventually, but it is incredibly slow. Informed search is way smarter. It uses a heuristic, which is really just a fancy word for an educated guess, to figure out which paths are more promising. Think about how your GPS works. It uses something like A-star search to estimate the fastest route instead of trying to calculate every single road on Earth. Next up, students tackle one of AI's first big successes, expert systems. You can think of these as the AI powerhouses of the 1980s. They run on a knowledge base of hard-coded if-then rules. Like, if a patient has a fever and a sore throat, then suggest a strep test. I mean, they were revolutionary for their time, but also super brittle. If you gave them a problem outside their pre-programmed knowledge, they would just break.
Okay, so that begs the question, right? How did we make the jump from those kind of rigid, rule-based systems to the flexible learning machines that define modern AI? Well, that's the next critical piece of the puzzle.
This hierarchy is probably the best way to understand the whole landscape. Think of it like Russian nesting dolls. Artificial intelligence, or AI, is the big umbrella term. Inside that, you've got machine learning, which is where systems learn from data instead of being explicitly programmed. And a subset of that is deep learning, which uses these complex neural networks. And right there, at the very heart of today's revolution, is generative AI, which uses all of this to create completely new things.
And to really get machine learning, you have to know the three main ways it works. Supervised learning. That's like studying with flashcards that have the answers on the back. Then there's unsupervised learning, which is like being handed a huge, messy pile of photos and told to sort them into groups, but with no labels. And finally, you have reinforcement learning, which is basically learning by doing. You get rewarded for good decisions and penalized for bad ones.
And then you get to the real game changer, the transformer architecture. This came out in 2017, and it's the engine behind modern marvels like ChatGPT. So what's its secret sauce? Well, it's a powerful technique called the self-attention mechanism. It lets the model weigh the importance of every word in relation to all the other words in a sentence, and that is what gives it that incredible, deep sense of context.
So all this theory, all these concepts, from search algorithms to transformers, they're all leading up to one thing, the big one, the final project. And this isn't just some exam. It's a challenge to build a genuinely useful and intelligent AI system from the ground up.
And the goal is laid out right here in the syllabus. And this is key.
It's not about just using a generic, all-knowing chatbot. No, it's about creating a specialized assistant that can answer questions using a unique knowledge base that the students themselves have to create.
So how do they do it? They use this really cool and powerful framework called Retrieval Augmented Generation, or RAG. Let me walk you through it in 4 steps. First, the students curate their own knowledge base on a topic they pick. Second, a model turns all that text into embeddings. You can think of them as numerical fingerprints of meaning. Third, when a user asks a question, the system retrieves the most relevant bits of info from that custom knowledge base. And finally, it feeds that retrieved info to a large language model to generate a natural, context-aware answer. It's awesome. But see, the course doesn't just end when the chatbot is built. The last part is all about turning you from a student into an actual real-world practitioner who can show people what you can do.
And this, right here, this is the real payoff. Students don't just walk away with a grade. They leave with a tangible, professional portfolio. They've got a working demo, a polished presentation explaining their process, and maybe most importantly, clean, well-documented code on a public GitHub profile. That's the thing that can show to any future employer to prove, hey, I can actually do the work.
This slide really brings the whole journey full circle, doesn't it? It shows the massive leap we've made. From the AI of the 80s, those explainable but brittle expert systems, to the AI of today. These large language models are incredibly flexible and powerful, but they bring a new challenge. They can be a black box, making it really hard to know exactly why they gave you a certain answer.
And you knew this was coming, right? With all this power comes a ton of responsibility. And that brings us to the final, and you could argue the most important part of the curriculum, AI ethics. The course really hammers home that being an AI creator isn't just a technical role. It's about a duty to actively fight bias, to be transparent, to make sure things are accurate, to respect intellectual property, and to always, always keep a human in the loop for the big decisions.
And that's where the course leaves you. It ends with this final, really important question. Not just for the students, but for all of us, really. Now that you have the skills to build these incredible tools, the real challenge begins. Deciding what you're going to build and how you're going to build it responsibly for the future that we all share.